Today we're going to work a service order for a voltage complaint. The complaint is the lights in the house flicker when the air conditioner starts and the dryer starts. Right now the transformer is a 50 kVA transformer that delivers 200 amps at 240 volts. We have 4-aught secondary for about 20 feet, and then it goes to the customer's riser. The main disconnect is 400 amp. He has a Tesla Powerwall feeding back into the grid. So what we're going to do today is remove the panel cover and add an exterior load that we control. We have a Super Beast and we have an external load box, and we'll set that up at 240 and let it cook while we monitor with thermal imaging. So, as in all our videos, what comes first? Safety. So we'll get our PPE on, our safety glasses, our hard hat, fire retardant clothes, and our rubber gloves. Because it's 240 volts, we can use a short cuff glove. So we're going to unpack the Super Beast. The Super Beast has the meter socket base on it, and we're going to connect it on one side. So white is going to go to the neutral bus bar so that it forces neutral currents back through all the bus and back to the neutral conductor. So we're going to clip it on right there. And then the hot leads, we'll bring them in and connect it straight to the bus. Right now the Super Beast says the voltage is 122 and 122. We'll put on a 23 amp load and let it start cooking. Right now we have the 23 amp on one side, and our voltage has fallen to 113 and risen to 130. We're going to let that cook and monitor with thermal, and we should be able to see the hot joint. We'll be using a voltmeter, trying to find out where our loss is at, but we're pushing 23 amps back to the transformer on the neutral bus bar, through his riser, back on that triplex, and back to the transformer. The triplex, the transformer, and our connectors are all fairly new. So we're looking for the loss that caused this neutral unbalance. Now this is a 120 volt load, but you can see that the riser neutral is not connected to the neutral bus bar. The riser neutral is connected to the sheet metal can. That's going to be a problem with 120 volt loads. Okay, 114, 129. 124 and 120. So without an amp meter, we don't know what's flowing on the neutral right now, but because the way this panel is built, the neutral bus bar is going through a bond into the sheet metal back to the neutral that is bolted to the can. Now I'm going to move that load to the right hand side. Our voltages start out 125 and 120. I'm going to make it worse. 130, 115. So now that we've got the Super Beast running at 120 volts, we're going to unpack the flicker buster, which is a 26 amp load, and we're going to move it to the other side. Right now the Super Beast is dumping 22 amps on that neutral. 21.6. Almost all of it is passing through the can, headed back to this lug that's scorched. On the back of that lug, where the lug bolts to that sheet metal can, it is scorched right now. So right now, that connector with 20 amps of neutral current is over 200 degrees Fahrenheit. So what we're going to do now is we're going to go ahead and connect the flicker buster, which will deliver 26 amps, and we're going to connect the neutral to the neutral bus bar, and then we're going to pick one of these hot legs to connect this on, and then we'll choose the position of the Super Beast to balance the load, semi-balance the load. Now we're going to bring on the third switch to deliver everything that the flicker buster can deliver. 26 amps. So the flicker buster is delivering 26 amps. Okay. Right now the neutral up here has 28 amps on it. This is passive, you don't have any motor load. Now I'm going to bring the Super Beast on and try to semi-balance these loads to try to see what our voltage drop falls to on a 240 volt, 20 amp starting load, 25 amp starting load. As we move 26 amps on this side, and it looks like 20, we had 4 amps on the neutral up here. So we had 120 volt load, 120 volt load, and when they're both running, we have 4 amps on the neutral. The voltage is pretty steady at about 121, 121. We're going to go ahead and let that cook. That's 3 amps on the neutral up here. 3 amps on the neutral. I'm 124 and 118 with 3 amps on the neutral. The Super Beast is off, the flicker buster's off. We're running less than 1/2 amp on the neutral. And my voltage measured is 125, 119. 125, 119 with 1/2 amp on the neutral. If I take my hot lead, we're at 240 volts. I'm going to clip on down here, and I'm going to see 119.6, 126.0. We'll come up here and check it on top of the breaker. 126.0 and 119. Now, the position of the neutral clip on the voltmeter is the most important. I'm going to take the voltmeter lead from the neutral bus bar down here, and I'm going to move it up here to where he thinks his neutral is, and that balances the voltage. So now I'm 122.8 and 122.8. Now, all the loads that are causing neutral unbalance are all tied to this jumper and this connector that's bolted to the sheet metal. These flickers that he sees may be coincidental with these air conditioner and dryer. A dryer does have a 120 volt load. The heaters in a dryer are 240, but the tumble motor is 120. And since I can see the back of this looks like a 750 lug is scorched against the sheet metal, there's a ton of resistance between that bonded neutral bar and this lug headed back to the transformer. Right now I'm going to blame all of the symptoms on the way that this riser has been built. All right, we're going to be able to talk to the homeowner about this and make corrections, and then if the problems continue, we'll be back to help him. Thank you so much for your time.